So hi and hello, welcome to our channel named Algebra Exploration. My name is Samir and today we are going to analyze the time complexity of building a Max Heap. In the previous lecture I have shown you how to build a Max Heap using an array and its pseudocode. Now let's analyze the pseudocode now. So by seeing the pseudocode you might think that the build Max Heap function takes n by 2 times. Why? Because it is coming from n by 2 and going down till 0. Okay, so this might take n by 2 times. Now for n by 2 times we are calling the Max Heapify function, right? So let's come to the Max Heapify function. Now in the Max Heapify function we are actually doing swap, right? And after swapping we are calling the Max Heapify function again for log n times, right? So this might take log n, right? So n by 2 into log n. So this is order of n log n. You might think that this might be the time complexity of this pseudocode, but actually we are wrong. How? Let's see. Now we can't do anything about this function. Actually it is running for n by 2 times only. But let's come at Max Heapify function. Now in the Max Heapify function we are actually swapping the elements, right? Now let's see at a particular height how many maximum swaps we are doing. Now when the height is 0, the number of swaps are 0. Why? Because they are the leaf node. Now let's come at the height 1. When the height is 1, let's say the parent doesn't satisfy Max Heapify property, so it might swap either with its left child or with its right child, right? So maximum swap happens here is 1. Now let's come at height 2. Now let's say again this node also doesn't satisfy the Max Heapify property, so it might either swap with its left child or with its right child. So this will be 1 plus. Now let's say this node is getting swapped with its right child with this one. Now again there might be a case that this node also doesn't satisfy the Max Heapify property, so it might swap with its left child or right child, right? So 1 plus swap happens at height 1. So the value of this will be 1. So overall it will be 2. Now let's come at height 3. Again here also let's say this node also doesn't satisfy the Max Heapify property, so it might swap with this node or with this node, right? So this will be 1 plus swap happens at height 2. So the value of this will be 2. So overall it will be 3. Now we know for a given node at height h what might be the maximum swap, but let's say we calculated the maximum number of swap for this subtree, but there might be a case that the swap might happen here also, and here also, right? So for height 1 there are 4 nodes, so overall 4 swap might happen at height 1. Here also for this subtree 2 swap happens, but here there might be a case that here also 2 swap happens. So at height 2 there might be 4 swaps. So let's see at a particular height how many maximum nodes are present. Okay, now the formula is actually n by 2 raised to h plus 1 taking seal value. So after putting the values in this formula, given that the number of nodes are 50, the answer we get is number of node at height 0 is 8, number of node at height 1 is 4, number of node at height 2 is 2, and the number of nodes at height 3 is 1. Okay, now there is another way also which I called it as a shortcut. Coming from height 0, what you can do, n by 2. Now for the height 1 just divide by 2 for this term, so this will be n by 4, again divided by 2, this will be n by 8, again divided by 2, this will be n by 16. Okay, now we will get and take the seal value only, so this will be 8, then 4, 2 and 1. Okay, now till now we know, given a node at height h, how many maximum swap will happen, and for height h, how many maximum nodes are present. Okay, so max Heapify is nothing but a number of swaps only. So let's see the total work done. Now at height 0, number of swaps are 0, right, into number of nodes are n by 2. Now at height 1, the number of swaps are 1 into number of nodes at height 1 are n by 4. Now at height 2, number of maximum swaps are 2 into number of maximum nodes at height 2 will be n by 8. Number of swap at height 3 are 3 into number of nodes at height 3 are n by 16, and so on. Now let's take n by 2 as common. N by 2, 0 plus 1 by 2 plus 2 by 4 plus 3 by 8 and so on, right? Now let's call this term as S. So S will be, and let's call this equation as equation 1. Now let's divide 2 in equation 1. So S by 2 will be 0 plus 1 by 4 plus 2 by 8 plus 3 by 16 and so on. Now let's call this equation as 2. Now we will do subtraction of equation 1 and 2. We get S by 2 equals to 0 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus and so on. Now this is nothing but an infinite GP, right? So the formula for this will be A upon 1 minus R, where A is 1 by 2 and common difference is 1 by 2. So this will be 1 by 2 upon 1 minus 1 by 2. So by calculating we get 1. So the value of S by 2 is equal to 1. So the value of S will be 2. Right. Now we have to put the value of S in this equation. So the total work done will be n by 2 into S. There will be n by 2 into 2. This will be n. So the total work done will be order of n. So the time complexity for building a Max Heap is order of n, not n log n. I hope you got it. So thank you.